Hello everyone and welcome to the Counting Atoms lab demo. So you should have a kit with a whole bunch of fun stuff in it. I'll show you in a minute. First we'll talk about how we actually count atoms in chemistry. Now atoms are super duper small, so we can't actually count them. We can't like sort them one by one with tweezers. So we count them in units using a number called the mole. And a mole is a value just like a dozen is a value. You have a dozen eggs, that means you have 12 eggs. All right, if you have a mole of atoms, it means you have 6.022 times 10 to the 23 atoms. Where did this random number come from? It came from a chemist named Amadeus Avogadro, who did some experiments with gases and different elements. And he realized that this number here is the number of atoms it takes to make an element's mass in grams match its mass in atomic mass units, AMUs. It's basically a conversion factor between AMUs and grams. So there's 6.022 times 10 to the 23rd AMUs per gram. So if we had some element, say copper, all right, copper's atomic mass on the periodic table is 63.55 atomic mass units. And if we had 63.55 grams of copper, that means we have exactly 1 mole, or 6.022 times 10 to the 23rd atoms of copper. All right, so in this experiment, you have a bunch of fun little stuff in your kit. All right, we have a scale, a digital scale, and we have a bunch of different items that you're going to be weighing. You're going to calculate the mass, and then you're going to calculate how many moles of these substances you have. All of these substances are pure substances. They are either elements, pure elements, or they are simple compounds, pure compounds. Elements and compounds are pure substances. And the compounds, I gave you the formulas for them, either in the lab or on the substance itself. All right, so again, anytime we're using our digital scale, we first want to calibrate it. If you need a reminder how to calibrate it, watch the density and measurement video. And this is also a little bit, there's in here a little bit of a reminder about tairing, because for some of these procedures, some of these things we can weigh directly on the scale, like the aluminum foil and the penny we can weigh on the scale, but for some of the powders, all right, we don't want to put chemicals directly onto the scale plate to weigh it. We want to put it in some kind of weighing device, like a weigh boat, or this thing's like a weigh pan, okay? And that way you can scoop into that weighing device. Now we don't want to include the weight of our pan, so you have two choices. You can either put this on the scale and hit tare to re-zero it and then add your material, or you can weigh the scale, record the weight, and then add your substance and record the new weight and do some subtraction in order to get the weight of your substance. That is up to you. Sometimes we have to do it one way or the other, and we'll see that in future experiments, but I won't go there right now. Alrighty, so the different things that you are going to be weighing. You are going to be weighing a penny. This penny is from the years that I can't remember, where pennies were made primarily of zinc. They're like 97% zinc, and then they're just copper plated. So we're using this as pure, we're going to pretend this is pure zinc for the purpose of this lab. We also have this little ball of aluminum foil, which I think is pure aluminum, but not positive on that. Again, we're going to go with that assumption. This is just an exercise. And we have some, what's our other, I think I have some tin pellets. I don't have them here. And then for our compounds, we've got salt, table salt. This is just salt from a salt shaker. Baking soda, same stuff you use when you're baking, some sodium bicarbonate, and some sugar, also known as sucrose, which is a pure compound. So these powdery things, obviously you will need to use a weigh pan or a weigh boat in order to weigh those. You're also going to be getting the weight of some water. So you have some kind of water squirter and a graduated cylinder. In this case, we're going to need to either weigh or tare the graduated cylinder before we add the water. Make sure that you add exactly 10 milliliters of water, 10.00 milliliters, please, as the instructions say. So you will record those masses in this table exactly as they appear on your scale, all of the digits on the scale. And you will also fill in the table with the molar masses of all of these substances, these 3 elements and these 4 compounds. And then you will do some math calculations to calculate how many moles you have of zinc in the penny and of aluminum in that foil ball, and so on and so forth. And then also how many atoms you have. Now, it's going to be a lot of repetitive math, so you don't need to show all of your work, but I do ask you to show your calculations for the penny and for the baking soda, so I can check your work and your process. There's also some post-lab questions here for you to answer, some slightly more creative or challenging questions, more application questions here that ask you to apply these math skills that you just exercised in this lab. That's a short one.